everyone. So lesson number 2 here, we get more formal. Oh, there's the bell to start class. We get much more formal in what we're trying to do because elementary school is all about counting the squares and the blocks and that kind of stuff. We're not going to see that moving forward. So let's take a look at some of these guys here of what we're dealing with. The first thing that we do in this lesson 2 is we do take a little trip down memory lane. And the idea here is, hey, we're talking perimeter that's here. So to deal with perimeter, we're adding up all the sides of a particular shape. So when you look at example 1 that's there, finally I got it up there in front of you here. It's a triangle. It's got 3 sides. Sorry, I'm looking for my writing tool that's there. And because it has 3 sides, we're going to add the 3 sides together. 8 plus 9 plus 6. We add it up. 8 plus 9 is 17 plus 6. Hey, 23. So it's just 23 inches. Hey, we're done. Show's over. It's not about just adding up all the numbers. Okay, I see 2 numbers there, 8 plus 5. Okay, wait a second. It's a 4-sided shape. So opposite sides have the same length here in our parallelograms. So now I can see, oh, I'm adding up 4 numbers there. All right, if I add all those up, I'm going to get 32. So 32. Oop, wait. Nope, I take that back. 36. All right, we're going to get 36 feet. That's there. But again, perimeter, add up the lengths of the sides. All right. Oh, look, there were answer blanks there. Sorry, you probably knew that. I'm sorry. All right. Area. Okay, so you played around this in elementary school, and what we realized is, yeah, it's just multiplying the length and the width. So sometimes the length and the width are at the top and on the left. Sometimes they're on the bottom and they're going up. That's there. Doesn't make a difference. The big thing here is they will always meet at a right angle, and that's the corners of your rectangle. Those are our right angles there. So yeah, we're just going to take 12 and we're going to multiply it by 44. I don't mind the use of the calculator that's here when it comes down to it. 12 times 44. Hey, 528. As we talked about, though, area is the number of squares to fill up the shape. We are talking meters here, I can see. So it's meters squared we're looking at. The next one, same idea. 16 times 16, all right? That length and that width we're looking at there. Multiply that, we're going to get 256. And yes, meters squared. Everything area is meters squared. If you look at the previous problems, it wasn't area, it was perimeter that's there. All right, so now we have our parallelogram. And the idea behind this is every parallelogram we can cut and move. So we're going to look at example 6 over here, just because I think you're going to visually see it a little bit better. We can go ahead and cut it. We can take this particular triangle, put it right here. Suddenly, we've got a rectangle. So what we're learning here is, okay, that works every time. There's a faster way of doing this. What we end up doing here is we do something called base times height. Now, here's the key thing. The base and the height always meet at the right angle symbol. So make a comment there, all right? Meet at right angle. So because it's a right angle symbol, all right, you can see it, there it is, that's your right angle symbol. We're going to use this guy and we're going to use this guy to multiply it. Because if we ended up cutting it and moving it to make the rectangle, that would be the length and the width. So it's kind of weird, like why don't we call it length and width? Length and width are only saved for shapes that come with the right angle. This is a parallelogram. Parallelograms don't have right angles. Rectangles do, that's why we use length times width. It's very similar though, but yeah, we're going to do that 10.7. We're going to multiply it by that 7. So we'll reach for that calculator that's there. All right, 10.7 times the 7. Whee! 74.9 centimeters squared. All right, so again, centimeters here, squared. So again, you're looking for that right angle symbol because that'll help you out with it. So again, we could cut it and move it. What we start to find out here is, no. We've got this formula here. Look for the right angle symbol. The right angle symbol will always touch the base and the height. So there's the 4. All right, connects with this line, so there's my 10. Yep, so 4 times 10, hello, 40. So 40 centimeters squared. All right, on to the triangles, which we've kind of seen this guy here from before with our visual, where we actually do make it into the rectangle, but then we divide it by 2. So again, base and height, because it's not always going to be a perfect rectangle that's going to come with right angles. Now this one does. This came with one on the inside that's there. So we can see the 9 times the 6, and then we'll divide it by the 2. So 9 times 6, 54. Chop that in half. Hey, there's an answer blank, isn't there? Yes. So 27 centimeters squared. So that's going to end up working here. It might look a little bit more awkward here, and we're like, wait a second, Well, technically what it'll do is it'll end up making a parallelogram. So that's why they're using the phrase base times height, because it's your parallelogram, but we only want half of it, so we're dividing it by 2. So again, this is why we have formulas, because you might be looking at it going, wait a second, that doesn't look right. You got to get away from the visual and trust the formula that's there. The base and the height always meet at the right angle symbol. So there's my 8. There's my 5. So 8 times 5, 40, divided by 2, hello, 20. So 20 inches squared. So that's what we're looking at here formula-wise. It's a kind of a trust thing. But again, base and height always meet at the right angle symbol. And yeah, people, that's what we're taking away from it. So, we'll see you tomorrow. I can just hit the pause button here. All right. Here we go. Here we go. You're good. Come on in. All right. I've lost the pause button here on the recording here, so it just keeps on going on and on and on until we can try to find it here.